Hi guys, welcome back again to my YouTube channel. Want to thank God once again for the opportunity granted to us so that we can learn together. And so guys, I welcome you to this video where we are going to look at differentiation of inverse function. And so guys, welcome. And so guys, we are looking at the question before us. But before we do that guys, we can read here where it says, before looking at this question, refer to video of integration, substitution of x is equals to tan u. So guys, refer back to my video and you shall see what there is there. Because guys, whatever we are doing here is differentiation. And we had already done integration of these functions here. And we know that integration is reverse of differentiation. So guys, now we are on our reverse direction. We were able to find the integral of tan inverse, not tan inverse, but 1 over 1 plus x squared. And we saw our results as this. And we were able also to find the integral of 5 over 3 plus 2x squared. And we were able to see our result as this. So today guys, want to see whether if we now differentiate, whether now we are going to see the same results. And so guys, we start our lesson today. So we look at now tan. The first one is y equals tan inverse x. So this one is going to be tan y is going to be equal to x. Now we come and differentiate with respect to y. We differentiate x, that will be dx all over dy. This is going to be equals to sec squared y, like that. So that now our dy dx will be equal to dy all over dx. This one is going to be now 1 over sec squared y. But guys, we know from the trigonometric identities that 1 plus tan squared y is equals to sec squared y. So guys, we can now replace our sec squared. So we shall have dy over dx will now be equal to 1 all over 1 plus tan squared y. So guys, finally we shall have dy all over dx being equal to 1 all over 1 plus tan squared y, because our tan y is equals to x, so you have x squared. So that is what we were supposed to find as our answer, guys. And so guys, when we were doing integration, we came from here and we added up here, that is tan inverse x. And so we are able to prove that whatever we found as tan inverse x was actually true. So guys, we now continue. So guys, now we look at this question, and this is how we go about it, guys. So we shall say, and put it this way, we bring this figures this other side. This will be square root of 2. We have 3 there, that is times all over square root of 3. Then we have 5 there, like that, still times there. Then we put y there. So this one is equals to tan inverse square root of 2 square root of 3 x. And so guys, we shall have tan of that is tan square root of 2 3 all over square root of 3 5 y. This is now going to give us square root of 2 all over square root of 3 x, like that, guys. Guys, we can bring these values on this other side, so that we shall have square root of, when it comes to this side, it will be denominator, this one will be numerator. So we'll have square root of 3 all over square root of 2. Then we have tan, like that, square root of 2. Then we have 3 there, all over square root of 3. We have 5 there, and then y, and that is equals now to x. So guys, now we can differentiate x with respect to y. So we shall have, this will be dx dy. We now come and differentiate this one. Here we have the constant square root of 3 all over square root of 2. That is a constant, so we don't deal with that one, we leave it as like that. We now come and differentiate this one. We can use the chain rule, we can use also the differentiation of tan. So the first thing you differentiate is tan of that, the whole of that, according to chain rule. So this one is going to be sec squared of the whole of that figure, square root of 2 3, like that, all over square root of 3, then 5, like that, and y. We have differentiated tan that, but now we need to differentiate in the inside, which now follows the chain rule. So when we differentiate in the inside, you'll have now this figure, because it's like saying 2y. Differentiation of 2y is 2. So the whole of this figure is now going to come here. So we shall have root 2, 3 there, all over root 3, and then we have 5 there, guys, like that. So that is our differentiation, guys. And so from there, guys, we can now find dy dx by getting the reciprocal of those figures. We now find the reciprocal of the whole situation, so that we have dy all over dx. So this one is going to be like this, guys. You'll have now square root of 3 now from here, then 5, and then you have the square root of 2, like that, all over square root of 2, like that, then you have 3 and square root of 3. We are getting the reciprocal of both sides. So this other one is going to be here. For example, this one is now going to be sec squared square root of 2, that is now 3 there, all over square root of 3, then you have 5 there, you multiply by now y. This now gives us dy dx, like that. So guys, we continue by saying this root 2 cancels that root 2, and this root 3 will cancel that root 3, like that. So here we are left with 5 all over 3, like that guys, and then we are left with a sec. So we can lengthen this one to be sec squared root 2. Then we have here that is 3. This is 3. Then we have root 3 there. We have 5 there. And then here we have y, like that. So this one gives us dy dx. So guys, now maybe I can now put my dy this side. So guys, from this equation 1, I've already arranged the equation beginning with that and then this. But we have this from trigonometry, 1 plus tan squared x. This one gives us sec squared x. And so here we have sec squared x. But from this, we have this value, guys, here. Sec squared x, we have from our equations, it is actually here. This is what now, guys, we are looking for. That one is what now we are going to replace here, down here, guys. So I can write it. I can now replace it down here. Let's say we call that one maybe equation 1. So I replace it with, before I replace, I'll have to replace with sec. To replace the sec, and then I can replace tan. And so first I replace tan before I replace that. So this one will be dy all over dx. This will be equal now to 5 all over 3. We now write, according to that, it will be 1 plus tan squared, now the whole of this, square root of 2, then we have 3 there, all over square root of 3, then we have 5 there, and then y. So this is what now we are supposed to now to replace with our values here, as shown. This one, it's here, guys. This is what now we are going to replace with. And so when we replace that, we shall now get, guys, this is what we are now going to get. You'll have dy all over dx. This one is equal now to 5. Put there 3, then 1 plus now our replacement, which is now, it will be now square root of 2 all over square root of 3 x, the whole of this is supposed to be now squared, like that, guys. Because the tan, if I show you here, guys, our tan was this is supposed to be our tan here. So when we replace, we get this. Now because it is tan squared, this is squared, this one ought also to be now squared, and that's what I have done, guys, here. So finally, guys, we have dy all over dx will be equal now to 5 all over, we have 3 there, then we have 1 plus, now this one is going to be 2 over 3 x squared, like that. That's what we are going to get. And so finally, guys, if we now multiply by 3 throughout, we shall get dy all over dx will now be equal to 5 all over now 3 plus, we divide 3 and 3, this one will get now 2x squared. And so, guys, we arrive at our answer. So this is what we were required to get. So, guys, thank you so much for listening to me. I'm so delighted we continue together to learn mathematics.